YouTube viewers. Today we're going to continue on with our in-depth look at the audio cards inside this tape recorder. We're actually going to go a step back here. I was trying to go in order from the first position, line input card. The next one was the internal NRS card, then the reproduce card, record card, and the HF driver card. I'm going to go a step back because I skipped over the internal NRS controller. Reason I did, I had no information at the time what it actually even did. But with the manual and everything like that, I've been able to piece together all the intricacies of this card and figure out exactly how it works, what it does, and how it fits in the big picture of the machine itself. So I think you're going to find this interesting because it took a lot of research on my part to figure this out, and I'm pretty happy because I now understand exactly how this card and its position works in this machine. So, without further ado, let's look at the internal NRS controller card. This is the internal NRS controller, or in other words, the internal noise reduction system controller card. It consists of two components, the metering board and the controller card itself. The purpose of this card is to interface with an additional noise reduction card, which could be Dolby A, Dolby SR, Telcom C4DM, or Telcom C4E. These noise reduction cards are installed in the rear of the audio card cage drawers. The controller card provides a digital analog converters and switching FETs, allowing for the Dolby card to switch between encode and decode and adjustment of input and output levels for the noise reduction systems in both recording and playback modes. In this particular machine, the optional Dolby SR cards are installed, which I will cover in the next video. So when I refer to noise reduction, I'm referring to these Dolby SR cards, but keep in mind that other options are available as mentioned earlier. To briefly explain the internal workings of this card, the noise reduction process involves two stages. First, the signal is encoded during recording, and then it's decoded during playback. We will dive deeper into this in the next video. As the input signal enters this card, it first encounters two FETs, Q3 and Q7, that switch between the input signal and the tone generator. The tone generator is used to set up audio levels on the card. The output from this switching network is then routed through two more FETs, Q4 and Q8, which switch between the input signal and the playback signal from tape. This output is then fed into a buffer amp, IC11A, before being processed by the digital analog converter, IC16A. This controls the level in 256 steps and stores it via the MPU in the front card cage. The signal is then buffered again through IC10A before being sent to the input of the actual Dolby card. In recording mode, the Dolby card encodes the signal, and at playback, it decodes the signal. Additionally, there's a calibrate mode. These three FETs, Q9, Q10, and Q11, send the signals directly to the Dolby card to control these three different modes. The output for the Dolby card returns to this card and is passed through a buffer amp, IC11B, and then into the digital analog converter, IC16B, to control its level. From there, the signal goes through another buffer amp, IC10B, before reaching these four FETs. In record mode, FETs Q1 and Q5 switch between the input signal, and the Dolby encoded signal. In playback mode, FET's Q2 and Q6 switch between the tape playback and the decoded Dolby signal. The remaining logic ICs handle sending and receiving data from the MPU, telling the card when to switch signals, how to adjust levels, and when to reset them. Now this small daughter card is the metering board that plugs directly into the internal NRS controller card. This board is responsible for both the VU and the PPM, peak program meter, ballistics of the bar graph meters. An important thing to note here is the internal NRS controller card plugs into the second position on the audio card rack. If you don't have Dolby noise reduction option, you would have either the internal SR/A controller card or the internal switching/metering unit card in this second position. On the internal SR/A controller card, the same metering daughter card plugs into it, like it does on the internal NRS controller card. But if you have the internal switching/metering unit card, the exact same circuit is built directly on the card instead of using this daughter card. A last note is, although you see a small trim pot on this metering card, and it is accessible from the back side of the internal NRS controller card, it is not to adjust level. Remember, all the meter levels are adjusted digitally on this machine. It's merely a DC offset adjustment for the circuit. A test point is provided right next to the trim pot to adjust for less than 100 millivolts of DC here in the meter circuit.
Well, I certainly hope that you enjoyed that, because that was a lot of work doing this video. It took a lot of research to figure out how this card worked and how it interfaced into the noise reduction system. Next week, we're going to get into the actual noise reduction system, so stay tuned for that. But hopefully you like this. Give me a thumbs up, because it was a lot of work. Subscribe to the channel, thumbs up if you enjoyed it, comment if you want, and hit the bell and I'll to notify you when I'm coming up with a new video. Thank you, and I'll see you then.